Yeah, I looked outside a couple hours ago and I was thinking, do I want to launch the drone? I was looking at clear skies, and then I figured I'd look back at what we shot a year ago, and yeah, we had to do that. Much more dynamic presentation. That's a frontal passage with some embedded storms back behind the front. That's kind of an anti-front that you're seeing, and rolling from west to east there 1 year ago. All right, we'll check out the current map. We've got high pressure. That's given us the clear skies in our part of Texas, and pretty good weather across much of the central U.S. all the way up into the Midwest. And what we see here is an warm air advection pattern right in this area right here. Maybe I should use red for that. Let's do that. And that's where we have the winds blowing out of the south or out of the southwest, and it's bringing up warmer air from lower latitudes. And then on the other side of the high pressure area, we've got cold air advection. And that's going to be in this area here, pretty much from Virginia, Pennsylvania, up to Maine and the Canadian Maritimes. So that's going to be cool air coming in from Ontario and Quebec. And we've got some pretty cool temperatures at this time. Let's look at those. Now, for those of you unfamiliar with weather maps, the value at the top left is going to be temperature, and at the bottom left is dew point. And to make the charts a little bit less cluttered, I went ahead and omitted the pressure, which usually goes in the top right. So going up to the northeast U.S., we see widespread temperatures in the 30s and winds running about 10 to 15 miles an hour, so very chilly weather in that part of the country. And as you go south, down the Appalachians, we get into the 40s. Winds tend to die down. And then we get down to Georgia, and they've seen a change of seasons in that area. 59 in Atlanta right now, 61 down in the Savannah area, and even down in northern Florida, it's in the lower 60s. So quite a temperature change, and we've got that north wind coming down through that region. And then on the other side of the high pressure area, there's the warm-up right there, and we can see that even though temperatures are in the mid-60s in North Texas, you go up north into Kansas, and ironically, it gets warmer. And we see mid to upper 70s in that area, right around, looks like around the Garden City area, and out towards Russell, and even up towards central Nebraska around North Platte. But up to the north, we see the next round of cold air coming down. Not a particularly cold blast right there, but that is a cold front, sure enough, heading south through Minnesota, Nebraska, and Wyoming. Okay, let's go through our usual chart sequence, and we'll back this up, and yeah, we'll take a look at tropical cyclone activity. That's been kind of a concern the past month or two, and we're looking quiet. Nothing expected in the next 40 hours, anything in the next 5 days? No, pretty quiet. However, out in the eastern Atlantic, kind of a different picture out in that area. Got a couple of cyclones. We've got Hurricane Willa. That's kind of a name that would be nice to have down in around Australia, where they call them Willy Willies. We could have Willy Willy Willa. But anyway, this Category 4 storm sustained 120 knots. That pressure is down to 946, so it's starting to get in that ballpark of a strong hurricane. Indeed, it's considered a major hurricane, being Cat 4, and the path of that is going to curve into the west Mexican coast right there. And then it'll begin a crossing over the Rockies, the southern Rockies, the Sierra Madres, around Tuesday, Wednesday, midweek, and that'll bring that moisture plume into South Texas. The circulation, of course, will be disrupted by the time it gets about this far, but the moisture field will certainly make it over the mountains. And just a quick look at the hurricane. There it is right there. Let me give you the date stamp at the bottom, and let's see if we can roll that. And pretty spectacular, very symmetric eye right there. Eye is very well defined on infrared. And I don't have the Dvorak images up, but I'm sure this would be showing as a major hurricane. And you see this outer spiral band, a couple of very strong thunderstorms rolling up the coast. into northwestern Mexico there. So that's what's going on out there in the East Pacific. And looking at SPC's side of things, with the increased shear across Arizona, the strong moisture, they've got a marginal risk area out for around Tucson up to Phoenix. And there's even been one report of a tornado on Interstate 40, about 20 miles west of Winslow. And this will give you a look at the thunderstorms. And we'll roll this back to earlier today. Looks pretty quiet earlier this morning. However, we can see some elevated storms starting to go up over the mountainous terrain north of Tucson. And this band of darker color, that's going to be the Mogollon Rim. That's higher terrain. That tends to be a favorite area for thunderstorms during the monsoon season. And another thing that we see here is all this low and mid-level moisture. Let me outline that, see if I can get that to go. Okay, it's going to be right in that area right there. That's a lot of stratocumulus and altocumulus, and that's probably helping to fuel these storms. So as we go through the morning, there they go. Some storms, looks like northwest of Globe. And then we've got this cluster right here forming just east of Flagstaff, and that's what produces that tornado report that was around 3 hours ago. And that's going to be out of these storms right here. Okay. And then, of course, begins updating. So that's a look at what's happening there in Arizona. And they're getting probably some of the most active weather in the U.S. at this time. All right, we'll go to the upper level charts. And for today, we're going to use the Canadian Weather Service. Let me zoom this out just a little bit. So we're looking up at 250 millibars. This is going to be up at about 34,000 feet. You can see we got northwesterly flow across much of the U.S. And the ridge position, upper level ridge running from the Texas Panhandle up to Wyoming. So what this means is that downwind from that ridge, kind of in this area right here, we would expect to find, for the most part, fair skies. And then to the west of that, in this area right here, we would expect to find unsettled weather. So that would be the Great Basin all the way down to Arizona and New Mexico. And that's pretty much what we're seeing this evening. However, embedded in this northwesterly flow, we've got a couple of Alberta clippers. You can see this indentation where the winds are kind of cyclonic. That right there is a embedded upper level trough. We may be able to see that on one of the charts I'm going to bring up shortly. And you can see another trough right here. Little indentation in the wind flow. But between those, we do have ridges. It's not very obvious, but there is a very flat short wavelength ridge right there. That would be a short wave ridge. And we would find another one probably right there over Lake Superior. So it's probably calming things down a bit downstream across the UP of Michigan and Lake Michigan itself. And then going the other direction up here in the Northwest Territories, another shortwave ridge. So you can see that we've got this mix of different scales of ridges and troughs. So we've got big trough right there, big trough out in the Atlantic, big ridge across the west coast, but embedded in that we find the smaller scale troughs and ridges. So there's a bunch of different things going on everywhere you look. Okay, let me check in on chat, see how things are going. I know we had kind of a dumpster fire of a stream back on Thursday, and what I actually did is I uninstalled the switcher program, or the mixer. That's this thing right here, and I switched to a much simpler version to kind of reduce the overhead on the stream. And I think we might be having good results with that. So keep your fingers crossed. Okay, JT out there in northern Illinois reporting 45 over 27. David Lumbert in central Arkansas reporting 49 degrees, winds calm, close to that high pressure area. Carl Berghoff is with us. Erica Baker, Coffeyville, Kansas, 58 over 41. Burl H is with us, and Alexi Pinkson-Walsh reporting 55 there in Texarkana. David Lambert appreciates the SKEW-T training. Yeah, we're going to be doing a few of those, maybe spending about 3 to 5 minutes on that this evening. Willie Greenway there in Georgia is with us, and Sam Hooker 51/41. And Dwayne Ward is joining us also. So back to the maps. Let me get my windows straightened out here, and we will proceed. Now, the next chart I'm probably going to want to look at is the 850 millibar chart, and that's this graphic right here. It looks kind of complicated. The main thing is to make sure you have your bearings, geography, land masses, and so on. So this is the U.S. right here. Then we got the Great Lakes, and then the northeast U.S., and then the east coast comes down like that to Florida, and then down to Texas, and of course Texas is right in there. So what I'm looking at mostly on this is the plots. That's these right here. So this is showing northwesterly flow, and we can see the temperatures in the top left of the plots. Now on the bottom left, we've got to ask ourselves, is that dew point or is that dew point depression? Because every site you go to uses a different expression. Now, one thing we can do is just go up to the northern areas and look at the values there. Dew point is never going to exceed temperature. So we've got these values here, -16, -16, -10. However, the figures underneath are much higher. We see 3, 5. So this is dew point depression. So this is basically the difference between the dew point and the temperature. So applying that to us in the U.S., Rapid City that we see right here, 18/20, that's telling us that the temperature is 18 and the dew point is -2 because we subtract that 20 from 18. So you might ask, why do you want to use dew point depression? Because you can't read dew point off of it, and you can't really correlate that to severe weather threat and stuff like that, because, for that we need dew point. So dew point depression is useful for approximating the relative humidity, and that can be important for finding cloud layers. If we see a dew point depression of 5 Celsius or less, that tells us the relative humidity is probably over 70%, and we would expect to find clouds. So where do we have that? Well, we find 30s in Minnesota. That's going to be very dry air. I'm going to use red for dry air. So there's dry air. There's 19, dry air, 30, and Topeka is dry. So all this is dry. So where we hit the humidity is out here in Pennsylvania. See, there's 3. So that's probably cloud material. There's a 1 there in Buffalo. There's 2 there around western Virginia. So if I outline the 5s, I'm going to get a map kind of like this here. And you notice that closely approximates the outgoing frontal system. So this whole area here, this is all likely to have clouds at about 5,000 feet, like in the low levels of the atmosphere. So taking that, we can probably assume that there's a cold front making its way eastward through that area. And in the wake of that, there comes the dry air from the Midwest and the central U.S. So that's how we would use this 850 millibar chart. And the driest air this evening looks to be in that area right there. Nashville to Little Rock and up to Kansas City. Okay, let's look at the thickness and isobars. So y'all are probably familiar with this chart, and what we see here is a baroclinic high across Kentucky and Tennessee there. We talked earlier about the warm air and cold air advection, and I don't know if you remember anything from Thursday when we talked about the boxes. See how we have this intersection of boxes between the thickness and isobars. The smaller that box is in geometric area, the stronger the advection. And we can see that the tiniest boxes off the East Coast are found right here. So there's very strong cold air advection taking place right around where that box is, and then this whole area right here, this is all cold air advection. That's coming in the wake of this frontal system heading out to sea there. And then on the other side of that high pressure area, we've got the warm air advection. So that's pretty easy to find. There it is right there. Now, that can be important because if the humidity in the atmosphere is high enough, this warm air advection out area will indicate the amount of lift and possibly the amount of cloud cover and precip. So if we kind of imagine the atmosphere is a lot moister, we would expect probably a lot of cloud to be forming in this area right here, kind of in the core of that warm air advection. So we would expect Chicago, Michigan, Indiana, and so on to be covered with cloud and the possibility of thunderstorms, but not today because it's very dry in that area. Up to the north, we see the next Alberta Clipper coming in from the north, and that's about where it is right there. And then we can also draw a little bit of a occlusion. There it is, and then the occluded low located right there around Churchill, just south of there. And then the next area of possible baroclinic development is going to be at that triple point right there. So if you were in Minnesota or around Thunder Bay, UP of Michigan, you might be watching that area right there, that little triple point, because this low here, that's going to end up gradually decaying over time, and then we're going to see new development at that triple point, because the atmosphere really likes to feed off of thermal gradients. And then going out to the west coast, looks like a quiet day out there. California under kind of a weak northwesterly flow, 1020 millibar high off the west coast, and then we see the next frontal system approaching. That appears to be heading for British Columbia, because these frontal systems, they tend to follow the thickness gradient, which means it's going to be tending to move like that. So we can assume that that low right there is probably going to end up in northern British Columbia, and then maybe come down the backside of the Rockies as a Alberta Clipper. So that's what's going on this evening. Now we're going over to the 500 millibar heights and vorticity. So this is up in the mid-levels of the atmosphere, about 18,000 feet. And here we can see the next shortwave coming down, extending from northern Manitoba down to Saskatchewan. And we can also see the jet max, not only in the wind plots, like I've drawn right there. It looks like the highest winds, maybe about 60 knots right there. Maybe about 65 right there. But also, that would be on the south side of these enhanced vorticity lobes. See that right there? When they're kind of elongated with the upper level flow, like you see right here, typically we're going to find the jet max on the right side. If you have your back to the winds and you're looking downstream like that, you're going to find the jet max to the right side of these vorticity lobes. So kind of in this area right there. So we got a jet max right there, and the jet itself located there, and that's going to be supporting that Alberta Clipper that's rolling southward. And that's what we would find there at the surface, maybe a front, something like that. There's our ridge extending from the Texas Panhandle up to Wyoming, and then out in California, looks like we got a little bit of an upper level low around the San Joaquin Valley. And in between, cyclonic flow and some 30-knot winds up at 500 millibars. And that's helping to support those storms that we have there in Arizona. All right, what's next in our chart sequence? I guess we can start looking at a few SKEW-Ts. And let's see, what should we do first of all, let me see if we have the evening SKEW-Ts. It's going to be the 22nd at 0Z. That's usually kind of hit or miss around this time because the radiosonde data is so fresh. And looks like we do have Fort Worth up, and this is Fort Worth about an hour ago. And we see lots of dry air. And by dry, we're talking about the difference between the temperature and the dew point. It's pretty spread out. And if you go up about 5,000 feet, much drier. Now we do have a little bit of higher relative humidity. That's going to be in that layer right there, indicating a little bit of cirrus at that level, and maybe a little bit more up here above 40,000 feet. And then we look at the wind profile to kind of get an idea what's happening there. We do have jet stream winds overhead, which is not a surprise because it's been kind of a cool day. And we do have a frontal boundary off to the south, an old frontal boundary. Still got a little bit of north flow in the low levels, and then those kick around to the west above 10,000 feet. Okay, so where else do we have weather? One area where we have a lack of weather is Missouri. Let's look at the Springfield sounding. We know that the air mass there is very, very dry. We don't have a sounding from them. I'm going to go ahead and switch this back to the morning soundings. And we'll look at Springfield, Missouri. And we can see how dry that is, especially in that 850 millibar level at that layer right there. So that's up about 5,000 feet, and we see that there's a tremendous difference between the temperature and the dew point. Very high dew point depression through that layer right there. So I'm sure the visibility in that layer is probably as clear as a bell there. And we see a very strong inversion from the surface all the way up to 10,000 feet. So that's going to suppress a lot of the vertical motion. And there we see some north winds coming out. So what's happening here, what the SKEW-T is telling me is that we've got a lot of cool air in the low levels spilling south, and we see near the surface the winds or the temperatures are in the 30s, and then they rise up to the 50s when you get up about 5,000 to 10,000 feet. Let's take it really far north. Let's go all the way up to, let's see, let's try Resolute. That's way up there in the high Arctic. Let's see how they're looking this evening. And the lines are all the way to the left. You can see the tropopause is pretty low. That's where the lapse rate changes from that to that. And that's up at about 24,000 feet. And we see even there at Resolute, they've got winds out of the north. And then at the other extreme, we can try Venezuela, or no, yeah, I guess that would be Venezuela. Let's try that, get a tropical sounding. And there we see the temperature and dew point lines are fairly close together. We see the easterly flow all the way up to about 25,000 feet. That's all trade wind because you're south of that subtropical high there. And let's try a couple more. Let's try Mexico City. Now, you notice that there's kind of a lack of detail in this sounding. I guess we haven't really discussed this, but you see how there's only like maybe, this has got a very, very coarse look. And that's because we're only getting observations at a few levels like that. Now the problem here is that there's probably instrumentation errors or maybe the way they're assembling it. A lot of times when we see this, it's because the significant level data is missing, because upper level data tends to come in with 2 or 3 bulletins, and if one of them are missing, we get kind of an incomplete picture. However, what we do see is that the relative humidity is pretty high, and we see a conditionally unstable air mass, which indicates possibility of thunderstorms with evening heating. And let's try one more. Let's try Oakland, California. Got to keep in mind that this is this morning. We see a pretty pronounced inversion there. Winds are out of the south, so that's inversion is not likely to be due to frontal passage. This is probably due to subsidence in the mid-levels. So we get a lot of heating of the column. It sinks and warms adiabatically, and we can see that just about 3,000 or 4,000 feet off the ground, temperatures are close to 70. But you go down a little bit lower and temperatures are close to 50. So those are the SKEW-Ts. So feel free to pull up a bunch, and let me give you the URL for that. Yeah, weather.uwyo.edu. They've got a good page there with upper air charts and soundings, and that would be a good place to look. And they do give you also different regions around the world. So we can go to Europe and pull up maybe Germany, the western part of Germany. Let me see if that'll come up. And there you go. So they're getting a pretty good northerly flow in that region. All right, so let's keep things moving and look at the infrared imagery. So there's how things are looking right now. And we'll back that up and see how things were earlier today. You can see the storms going up there in Arizona due to that strong shear. And then we can take a look out in the eastern U.S., and there's a lot going on there. And you can see these streaks coming off the East Coast. So what might be causing those streaks? Let me run that forward. You notice how they're kind of anchored to the coast right here. This is actually, it's basically lake effect clouds, except, you know, this obviously isn't a lake. This is, however, the mechanisms are the same. You've got very cold air coming out of Canada, passing over the cool terrain, but as soon as it hits the warmer waters offshore, you end up with a situation where you're adding a lot of heat to the bottom of the column, which means you have a cold over warm situation, which, as we know, is a very unstable temperature profile. So by adding that heat to the bottom of the column, you're increasing the cold over warm difference, and you're making the atmosphere more unstable. So it's actually this modification over the warmer waters. That's what gives us a lot of these clouds. The clouds start appearing as the convection starts building, and you end up with a lot of stratocumulus offshore. So it's basically the same thing that we got going on in the Great Lakes. And then just a quick look at Texas, bringing up moisture from Mexico there. This is all high clouds. However, if we switch over to visible, you notice a little bit of a difference here. A lot of this cloud around the Rio Grande Valley is kind of fibrous, but if you look out around the Big Spring and Lubbock area, there's a little bit of mid-level cloud floating through that area. So probably a little bit of a different mechanism taking place there. And let's check out the infrared imagery. And it's kind of hard to see underneath because you can see these high clouds really tend to obscure the lower clouds on infrared imagery. See, can't really see any trace of that mid-level cloud. However, in the visible spectrum, high cloud is very transparent. So now we can really see what's going on. So it does pay off to look at both visible and infrared imagery if you can, because there's different kinds of information on each one. Okay, I think we've run through most of the charts there. It's kind of a quiet day. Let me switch over to chat, see what's going on. Okay, Dwayne Ward reporting crystal clear on the Delmarva. Carl Burkhoff reporting clear in Wisconsin, kind of cool. Dwayne Ward mentioning a meteor shower peak tonight. Yeah, I've been kind of out of touch with the astronomy stuff. I know the Leonids, those do tend to be very impressive, but I know those come more into like the second week of November usually. So I'm not really too sure what we've got going on. Maybe one of you knows for sure. Yeah, full moon, yeah, those can definitely mess up meteor viewing. But you never know. Let's see. Andrew Hotchkiss asking, how do cloud streets set up in the lines? Just a bunch of stratocumulus clouds. Yeah, whether you get streets or transverse bands, that's kind of a function of shear there. However, a lot of the clouds that we were seeing on that image right here, yeah, a lot of those are going to be cloud streets because the flow at almost all the levels in the low levels are pretty much out in the northwest. So there's not a whole lot of directional shear going on. So we do get, you do tend to get cloud streets in these strong lake effect situations in the wake of a cold front. Usually when we see transverse bands, and I don't have an example of that here, but we tend to see that in warm air advection patterns where we have strong directional shear going on. And maybe we'll have an example of that coming up in several days, and I'll show you that here shortly. Because I think we're about to get into severe weather season in the next week or so. Okay, we'll look at the upper level charts, and let me bring my windows back. There we go. So we're looking at the mid-levels. This is the GFS forecast. There's how things look this evening, and there's Willa showing up very plainly at the 500 millibar level, and that's going to be tracking up towards Texas. So we're going to expect to see that on this forecast run here. We've got the cutoff low in California. We've got the ridging in western Canada. We've got the Alberta Clipper coming through. There's the reflection on the upper levels. And then we've got that major trough offshore. So those are the main features we're looking at. And the other thing that we're probably going to be seeing is this jet max. That's probably going to be kind of a big thing in about maybe 5 to 7 days. The jet stream is running something like this. And the jet max is about right here. So you remember when about 10 minutes ago, I was talking about the higher vorticity. You've got your winds, you're back to the wind. So you're standing about right there. You're looking downstream in that direction. And you'll notice that the jet max will be to the right of the higher vorticity. So that's going to put it in this area right here. So jet max right through there. And that's got a good chance of breaking down this ridge, so we're going to see shortly. Okay, so we'll roll that forward. Jet max is rolling on in, starting to form some shortwave advection lobes there. That's probably heading for British Columbia, and then we see Willa about to come on shore. Looks like that cutoff low in California is starting to open up a little bit, moving into the Great Basin area. Going into Tuesday and Wednesday. So Will is making landfall sometime Tuesday evening. Here's the first trough coming on shore into Washington Tuesday evening. Jet max located in that area right there. So yeah, it's starting to break down the ridge, kind of squeezing it there into the Canadian prairies. But the whole system is kind of going north at this point. Got a little bit of troughing coming in from Baja California. That may make it into Texas. Roll that forward some more. Yeah, here comes the troughing. And that's sinking up there, coming into phase with the remains of Willa for Wednesday evening. So I'd expect to see a lot of rain starting to pick up in Texas around Wednesday. Other than that, pretty quiet. A couple waves coming onshore. Here's a couple of them lining up off in the Pacific. And let's see what the next change is going to be. Looks like around Friday we see northwesterly flow starting to pick up once again. A couple of Alberta Clipper type waves coming southward. And one of the first ones coming in for Saturday into the Midwest. So that would probably be associated with a cold front diving south, kind of like that right there. Starting to look pretty stormy out in the Pacific. Some major troughs for next weekend. Looks like these probably have a good chance of moving inland, especially since that ridge is not built up very much. So let's see what happens. Okay, first trough coming into the Pacific Northwest about a week from now. And then this one appears to be diving southeast. See that right there? And this is coming down. If you zoom out and look at the entire troughing pattern, this whole thing, this is kind of a big long wave trough, and these troughs are coming down the west side of that trough. So they're coming down this backside here, and that's a good indication that those are going to amplify a bit. So kind of a series of troughs coming in for around Tuesday, the 30th, the day before Halloween. And then this next one really digs in. And this is not a cutoff low. This is an actual baroclinic system. So we're probably going to be seeing some winter weather in the mountains of maybe the Sierra Nevadas and Utah. And then that will start taking aim on Texas around midweek. Not this week, but the next one. And we see this very well-developed southwesterly flow setting up across Texas. Southwesterly flow in the cold season tends to be a wet pattern. And then we've got that system pulling out into Texas around the 2nd or 3rd. And I'm going to show you the ECMWF and what that's got. Actually, this is interesting. Get out to the 5th, and there's like another trough lining up. And that one, yeah, so we're pretty much lined up for some wet weather. It's kind of a classic El Nino pattern. All right, let me get my cursor back, and we'll look at the European model. So we're only getting this European model at 24-hour intervals, but we can see Willa coming on shore, matching up very good down there in Mexico with the GFS. So keep in mind, this is we're looking at European data. This is a European supercomputer solution. Next big change after that appears to be coming in for midweek next week. Not this week, but next week. So this is around Halloween, and you can see that the European model is really digging that trough in the morning of Halloween. Let me give you a quick comparison. Morning of Halloween is going to be like that right there. So there's the GFS American solution. Very well-developed trough in the southwestern U.S. You can see that the Jetmax is in Baja California. This is 230 hours out. So this is kind of a ways out. And then we compare that to the European solution. And it's got that trough going a little bit faster, but still with all the same intensity. And with this particular European solution, I would expect to find a higher risk of severe weather in Oklahoma, maybe northwest Texas, and southern Kansas. And we will have the moisture in place. Let me show you the GFS solution for dew point. So we can see the moisture surging. Yeah, I need to cover that system. We'll come back to that. Anyway, yeah, around the 29th, we see warm air advection starting to set up in Texas. And then for the Halloween, this cyan color, this is 60s dew points, and it's got it all the way up into Kansas, and then 70s coming into the Interstate 10 corridor. So we very likely have enough ingredients for a round of severe weather around Halloween. I would say the GFS supports maybe some severe storms in northwest Texas like that, and certainly the European model in the same area. So this will definitely bear watching. Now the other system is the northeast coast system, and we see that coming together off the coast of Texas, and this is with the remains of Willa. Let me zoom out just a little bit here. No, it's too much. Okay, yeah, just keep an eye down here in the south part of the chart. See, there's the remains of Willa around Wednesday, crossing the mountains, interacting with this cool northeasterly flow in Texas. So southwesterly flow riding over the top of a cold dome, that's going to mean lots of precip. So looks like kind of rainy around Wednesday or Thursday for Texas. And then as it comes into the Gulf of Mexico, you can still see the circulation right there for Wednesday evening. It starts picking up that frontal gradient and becomes baroclinic. So we have a new frontal system developing along the Gulf Coast around Thursday or Friday. So that's going to move eastward into the Florida area around Friday. and then start making its way up the Gulf Coast, or up the Atlantic coast, interacting with the Gulf Stream waters. And that gives us kind of like an early nor'easter storm coming together. So there it is right there off the coast of the Carolinas on Sunday. And then the occlusion coming up into Long Island for Sunday evening. So this is going to be about a week from now. It does look like it's probably going to be a little bit too warm for very much snow. Let me see if I can bring up the precip chart. Yeah, I'll show you the system coming together. You can see Willow coming together there in Texas. Bear Clinic system coming together in the Gulf of Mexico area. Thunderstorms across northern Florida. And there it goes up the coast. And looks like most of that precip in the New York City, Boston area is going to be liquid, but you go up into Albany, Vermont, New Hampshire, and maybe Scranton. Looks like a chance of snow in that area. And then after that, looks like a lot of latent heat, kind of changing the situation there, warming things up, and a lot of that changes over to rain around Monday. So anyway, not a whole lot going on right now, but things are going to get active in about 5 to 7 days from now. Checking on chat there. Chris Tyne had a good view of the Perseids this year. Now, if I'm not mistaken, I think the Perseids is August. Is that correct? I'm not sure. It's been a while since I've done my astronomy stuff. Dwayne Ward mentions the Orionids is the current shower. Okay, appreciate that, Dwayne. Pataniki, Patagonia, Arizona, unexpected rain, cooling and thunder. Yeah, getting some of that severe weather out in that area. Big coastal storm for the East Coast, and we've just covered that. Dwayne Ward says, nice negative tilt on that trough for the coastal storm, and very good. I think we have had a smooth stream here, and I've only dropped 46 frames. So maybe a lot of our problems have been due to that old mixer program. All right, well, this is a good development, so hopefully we can stick with it as we get into Tuesday's show, and maybe we'll have another good one coming up here in a few days. All right, you all take care, and we will see you again on Tuesday, 7 p.m. Central. Until then, have a good evening. Bye-bye.